Hello and welcome to this short unscripted video. I just wanted to show off a little side project that I've been working on while I've been doing other things. Well, hello, this is take 2 of this video because I actually recorded this last night and, well, I just didn't like it. I reviewed some of the footage and it came out really badly. This is a somewhat short, unscripted video that I wanted to show off a project that I've been working on in the background next to one of these. So, out the way, because the focus is what's going on here. I'm building a smart knob, a dynamic haptic feedback smart knob. This project is heavily inspired by Scott Bezek's smart knob project that he released earlier this year. A dynamic haptic feedback smart knob is basically like a rotary knob or rotary encoder that has dynamic indents or spring-back effects, and it uses a brushless motor to create those effects by creating a resistance against the dial's rotation. Now, one of the issues Scott Bezek has now faced with his design is that the motor that he used for his smart knob is no longer available. Because of the popularity of his project, the old stock that he was using is now sold out. I don't know if that's now been replaced yet, but at the time that I started working on this, that seemed to be a real issue. So one of the main goals of this this project was to create a integrated custom motor design in the package, and this is what this part is. Well, this part is what would be the stator. Now, this is just a 3D printed representation of it, but this would be made from something like either mild steel or ideally I think it's silicon steel or electric steel, which creates a better flux, or at least makes a stronger flux to work against on the motors. Now, I wanted to show off this very first prototype that I printed off. Now, there's no hardware yet, it's just purely the mechanical-ish side of things, but none of the PCB design has been even started yet. The electronics is still very much up in the air or non-finalized, and let's not even get started on the software. There is no software yet. That'll be something that'll be done later, way down the line. Now, I'm planning to work on this project fully probably next year now, because there are several things I need to get on with, including the updated version of the hardware monitor. And I also really want to get back to work on the Stargate and at least get the next stage of that finished. So that's going to be done probably over the Christmas period. So I wanted to show this off in the meantime because I've been working on this in the background while working on my new tricorders, and I printed off this test just to get, just to have a little feel of it, see, what I need to work on, and there are things that need to be working on. There is going to be changes to the CAD design for this, just mostly minor changes, but mostly a case of needing to create better clearances for things, because some of the parts rub up where they shouldn't really be rubbing up against each other. Some of that could be down to not having enough tolerance in my design. Some of it may be down to the fact that resin prints aren't perfectly dimensionally accurate. They can sometimes be a little bit of give or take, whether that's due to inaccuracies of the particular machine or even the particular resin expanding or contracting while it's curing, or also just down to the print settings, such as I might have the cure time a little bit too long, which creates a slightly over cure, which expands the resin diameter slightly. But anyway, those things now need to be changed to fit for those allowances. But yeah, these are the core parts of the smart knob. Now, very first thing I want to show is this very old back box. Somewhere in the house I've actually got a newer one. I just couldn't find it in time for making this video. But the idea behind having this back box is this is a standard back box for the UK, though this one be an older design. But the shape and size is pretty much a fit standard, at least in the UK. I know that America has different light switches, but for the most part, this is a UK one. I don't know how different it is in places like Europe or Australia, but I built around this design. And the reason why is because this is a front plate for the dial, and the idea was for this to fit on a standard back box, particularly because my first project is probably going to be something like a smart thermostat for my home, and hopefully this will be something that will be built, as I said, let's say next year. So having a plate that fits on a standard back box was one of the main first parts of the design. Now I'll be going to that a little bit later, but I just wanted to get that part out the way, the reason why it's shaped the way it is, and why I've made some of the design choices the way I have. I'll talk about the faceplate shortly, but what I wanted to do first was second, I wanted to get on with the putting this together to show you what or how it's going to come together. Now, one other issue I do need to also address, which again is partly down to one of the corrections I need to make, is this is a frame, but it's also buttons, but it's a frame to hold the LCD. Again, this is ever so slightly too small. The frame doesn't, the LCD doesn't quite fit in the frame perfectly. I can get it in there, but it's a really tight squeeze, and it doesn't really want to go in there. That's something I'm going to have to fix. This could be, again, down to the issues I've already mentioned, or potentially that the CAD drawing that I was working off wasn't quite as accurate as the actual piece. So I'll be double checking that, and I'll be working towards making that an easier fit in the future. Let's start putting this together. To begin with, though, I want to talk about the stator. This is still very much an early sort of prototype idea, or in the idea state, but the idea will be that the stator gets keyed on and possibly glued in on this inner the inner bearing frame. Having the stator made is going to be a challenge. I may have to get this made by a company, either, I don't know, in China or in the UK. But getting electric steel seems to be really difficult in the UK. At least there doesn't appear to be any readily available supplies that I can find. And then I'll have to then stamp it or have this laser cut somehow by another company, because my laser cutter won't cut steel. It's not that powerful. So that's something I'll have to work around in the future. But for the moment, I'm using a 3D printed part purely for sort of like fitting this together and figuring out how it's all going to work. Now, as I mentioned before, this is the very first printed prototype. It's not perfect, there are issues, and I will be making changes in the future, mostly tweaking some clearances and some parts, because, you know, bits shouldn't be rubbing up against each other, and there may not be enough space to even fit the coil, three-phase coils that I'm going to be wrapping around these stator bobbins, I think they're called. But yeah, they're going to be quite small, and this is where the other issue comes as well. Because of the size of this and because of the small magnets that I'm using that are going to be placed inside this ring, which I will show shortly, I simply don't know what the power is going to be like. I don't know what the torque is going to be like. There is a maths behind it, but I don't know it, and it's definitely a level of physics that I am not prepared to really go into at this stage, or even learn, because I don't know it. Most of this is trying it out until I get it right, and it's not the best way of dealing with things. Perhaps a proper engineer would go into the maths of that, and I don't know how to calculate magnetic fluxes, so that's not going to happen here. But the stator gets pushed onto the inner bearing ring. I'm going to put that down for the moment and quickly go onto the dial itself, because this is where a lot of the interesting stuff will be happening. And again, early prototype things are probably going to change, because I'm not convinced this is going to work now I've seen it in its printed form. I'm going to zoom in, and hopefully we'll be able to see this a bit more clearer. Hopefully we can see it's a bit more clearer now. I will show the 3D model as well, just to help it a little bit clear, to help it make it a bit more understandable. But if you see inside, I've already fitted one, there it is, one of the small neodymium magnets. Now they fit in these slots, and they'll be wrapping around there. Now these things are tiny, and I simply don't know for sure if they're going to be powerful enough to give a good amount of torque with the three-phase setup of the stator. Now it's going to be in a Y configuration, because I am aware that that has a better torque level. I'm hoping that the magnet perhaps times with the number of actual magnets that are dotted around, and the number of windings on the stator. It all hopefully will add up to a decent amount of torque to give the effect of, let's say, indents and the spring back effect of the motor. But again, I won't know that until I start testing it electrically, and that's not happening for a while yet. But the magnets get slotted into these slots, and this ribbing that you can see on the inside, the plan would be to paint the high peaks of these ribs white or in another reflective material, because I'm planning on using a infrared encoder sort of setup. It's a custom design using two infrared detectors and one infrared light placed next to each other, offset to create a standard encoder signal. But again, I'm not 100% sure this is going to work accurately. There's a lot of sort of like planning in this. I may end up replacing these ribs with a gear key, and maybe have it on a gear that rotates, and use a magnetic encoder similar to what Scott Bezek used in his project. But fitting all that in this rather small, or at least compact design is definitely a challenge. And at the time, it seemed that using a optical encoder would probably be the best option. But seeing this now, I'm not 100% sure if it's going to work, because it is, as I said, it's quite small, and optical encoders may end up just getting a blurry image of everything, and I need to figure out how to fix that. There may be something I just have like a really tight slot on the receiver. I don't know yet, but that's something I'll be working out in the future. But that's something I just wanted to show with the ring, because this is where obviously you use to turn, but also where all the magic happens, essentially, of the rotary encoder and the haptic feedback stator motor. Anyway, I'm going to zoom out and we'll start putting this together, and hopefully we'll get an idea of how it will work. Okay. Now, the absolute order, there is no strict order for the most part of what these go together, but it does help to get certain things in one particular order. So let's start with getting the bearing in the outer frame. Now the outer frame is what essentially couples the bearing to the dial, and it also doubles to help space out and strengthen the entire thing. The bearing slots into this outer frame, and if you look carefully you can see there are these little clasps that hold onto the bearing. Now on its side they can be, still be released, but for the most part they hold on to the bearing. And there's also these holes on the side, because inside here there will be nuts, little miniature nuts that I would use to screw and secure this onto the frame. But they also double, because when the screw goes in it pushes up against these little clasps, which really hold onto the bearing and clamp onto the bearing tightly, which makes it basically next to impossible to remove this without breaking anything. So you'll have to use quite a lot of force to accidentally make the bearing slip out, essentially. So the bearing's onto the outer frame. We're going to then attach it to the inner frame. Again, on the inner frame there are these deflecting clasps that hold on to the bearing, and they're they pull off fairly easily, but they're not a terribly strong clasp, but they do hold on to it well enough. And also because of the orientation, when everything's all attached there is no way to accidentally pull anything off, because it all is sort of like holding on to each holding against each half. Yeah, that's what I mean to say. Pushes against each other, so there's no way of accidentally pulling things apart. With the two parts of the frame attached, I would need to place the LCD frame and button frame on top of here. Now, one of the things to be aware of, there clearly isn't any PCBs on here yet, but I have designed a space for a PCB to go into this slot here, but also a PCB will be possibly glued or attached to the back of the LCD frame as well, because the ribbon cable for the LCD comes in, attaches to the LCD, but also, as I mentioned previously, these are going to be buttons that rotate around or are placed around the LCD, and the actual physical button will be on the PCB that sort of spreads out around the edge across here. I'll show that more clearly on the CG CAD model. But that then gets placed onto the inner frame. Now I need to double check, because when I made this video yesterday and really messed this up, I also got the orientation of the thing wrong, so I want to make sure I've got this right. Okay, yep, so that's top, that's bottom. Okay, the LCD frame will be placed on there, and I have bolts that go through the bottom, securing it in place. Now it's all a bit awkward to do on camera, but I'll try and screw these in. Now I'm not going to do every bolt in here, but it's purely for the demonstration of the video that I'll do some of them. And same for the outside ring. There are 6 6 bolts that go around the edge. I'm not going to be doing them, but you get the idea of how they're going to work, hopefully. So the LCD frame is now secure to the stator and inner frame. The inner frame will have a PCB on top. There'll be a PCB on the back of the LCD, and there'll be a 2mm gap between the two PCBs, and they'll be using a board-to-board connector to connect those two. The top PCB will likely hold the Eve chip that I'm going to be using. So yeah, again, I'll be using an Eve chip just like I used in the tricorder to drive the display on here, and the backlight and all that would probably be based on this board, though thinking about it, the backlight probably would need to be on another board because of the height. But anyway, that'll be the board that holds that and holds the buttons. There'll be the second PCB here, which will hold the ESP32 that would be going on there, as well as a motor driver IC, probably something similar to what a stepper motor driver for 3D printers might use. Is it TCM? Oh, I can't remember. And also the stator will be soldered, probably somewhere around here, to that PCB as well. Anyway, the stator, the LCD frame, inner frame, and outer bearing frame. Next would be the actual dial itself. The dial simply fits on over here, making sure to line up the holes with the other holes, and it goes on quite simply like that. The screws will then be put through, the bolts will then get put through, which are then pressed down onto here, securing it onto the ring, onto the bearing, and there'll be no way of pulling that away. Now, this part will be pretty much sealed here and finished. But I've still got to work out whether I'm going to be using a connector or a sort of like a wired loom with a plug or some other type of like way of connecting, because what's going to happen is inside the back box I would likely have the power circuitry for this. This would be stuff like converting, whether it would be mains or even 12 volts, which is I believe what most boilers run off, is a 12 volt system. There'll be the DC or AC to DC converter stuff would be placed inside here to power the actual project. But I wanted it to be modular so that the power can go in here, but all the digital stuff goes off inside here, because this is not just for something like a smart thermostat. I could use this for other things, including, yes, light switches or smart home type setup, but also a clock or a smart speaker, which is another thing I want to use this on. But for the sake of this setup, I created the front plate, this front plate to fit onto these standard sort of back boxes. Now straight away you can see there's an issue. How do I fit the dial with the back box on here when the screws are hidden behind the actual dial? Well, I had to create a lock-in mechanism for that. So the idea would be that this gets placed onto the back box with the screws going in, and this is another thing I need to fix out because I just realised last night the holes are too small. So I can either drill them out for this, or I could just fix that in the design later. And you can also see by the scratching, there is something else I also need to fix, is that these rub up against the face a little bit, and that's where this scratching is coming from. I'll have to create a little gully in the face there to accommodate these little bits. This is not a big deal. This, like I said, this is the very, very first full print prototype to see how things work and how they fit. And I knew there was going to be issues, and it wasn't going to be the final version by any stretch. Now, this gets placed on to this faceplate. There's a very specific keyed out indents here to fit the inner ring, and the reason why I've done that is to enforce the orientation as well as having a good lock, but also that I needed to create a locking system that would make it relatively easy to remove. So at the moment I haven't got the locking mechanism attached to this because straight away when I was trying this out yesterday I actually broke it. So that's clearly another part I need to fix in the design, is to make this a stronger part, making this thicker perhaps, and maybe re-evaluating some of the dimensions a little bit to, one, make it easier to move inside there, but also to make it not so easily snap. But the idea behind this will be, with this locking ring inserted inside here. Now the idea this is meant to be quite freely to move. It's meant to freely move up and down inside this ring with springs that hold it in the locked or closed position. This button system would be placed on the inside. There'll also be a perspex or another flat screen to hold everything in place, but for the sake of this demonstration, the button would be like on the bottom here. You could then push the button up, which would rotate this locking mechanism up and would push these locking jaws away from the actual little bumps that are on here, which would otherwise securely hold them in place. So when this is getting fitted, it's falling out again. So when it's getting fitted, the button is pressed in, and the faceplate, the dial is then pressed on and the button is released, which would then have this rotate clasp lock down and hold the dial in place. But as I said, this is broken at the moment and I need to redesign that part. So that's be in place, and then you can just rotate the dial. At the moment, some bits are rubbing up against each other inside there. I need to rework some of the clearances and tolerances inside, because obviously that needs to be as freely moving as possible. That is essentially should be flying on a bearing, but it isn't. It's rubbing up on bits and pieces at the moment. Some of that is actually down to some of the artifacts of printing, such as the support bumps, but some of it is just probably not enough clearance in the design itself. But yeah, that is the dial. So the idea would be you use the dial to rotate your settings or controls, but there's also the buttons on here that would be like option buttons, like an OK button, left, right, maybe an up, down, or probably just use the dial for up, down, and use these for the various different options. But in the end, this is an interface device. It's not just a thermostat, it's not just a radio, it's not just a clock. It's an interface device that could be used for various different things. I might even end up making a USB interface device to make like some kind of like rotary encoder system for CAD work or editing and whatnot. Now, one of the things to mention as well, with the LCD in place, this LCD is just a bare LCD. There is no touch screen on this, and annoyingly, the only touch screens that I seem to be able to find are not perfectly round ones either. They have this shape, this sort of like cut-off teardrop in the design as well, and they won't be ideal for this kind of like setup. So there won't be any touchscreen on this. I would love to have had a capacitive touchscreen on here, but that isn't possible. So for this project, with the screen inside there will just be either a perspex or polycarbonate screen on top. As well, I would like to have had, like I say, a quartz or glass, but getting some custom glass or custom quartz made may not be cheap. I may be able to find some glass, but quartz almost certainly won't be cheap. And the plan would be that would be possibly glued in around the edge or on top of the LCD, but that's still something I've got to work out a little bit later. But yeah, that's the project as it is for now. So this is very much the first prototype. There will be more work done later, but like I said, probably next year now. And I want to be getting on with some other projects, including getting these builds done. They'll be done hopefully in the next, I don't know, month or so. And I've got other things I want to be getting on with over the Christmas period. Now, the design files for this project will be placed up on my super support tier of the Patreon page. So if you wanted to download this and have a look at it yourself, or even just build one, by all means you can, but be very well aware that this is the first prototype. It doesn't work as it is. It still needs a lot of work done to it, and it's there purely for preview purposes only. But the files will be up on my Patreon page, if not already, very shortly. So if you want to go and support me, you can sign up to the super support tier, or if you just want to support me generally, sign up to my Patreon, and you'll be helping me pay for the various tools and materials. For instance, this is Soriatex Obsidian Black Blue resin. It's meant to be their one of their strongest resins, much more like ABS than the Elegoo that I'm used to using, but it still breaks. So I'm not quite convinced it is as good as ABS, but it seems to be an interesting resin. So I'm going to see how that goes in the future. It is different to the Elegoo ABS resin. I'm going to give it that, but I'm not convinced it's necessarily that much better yet, but we'll see. Anyway, this stuff is more expensive than the Elegoo, so the support that I get through Patreon, or even a GoFundMe, if you want to do just a one-off donation, you can do me. I've got the links in the description. All the money I get helps pay for these materials, and also pays for the tools that I use to build everything. So if you want to help support me, you can do so through the GoFundMe or through my Patreon page. I'm now going to stop shilling that, so thank you very much for sticking around in this video. I hope you like this unscripted, completely ad-libbed, and you could get through my stumbly speech pattern. It's awful. I do stutter. It's not great, but yeah. I hope you enjoyed this video. So thank you again. Stay safe and take care. Bye-bye. Also be keyed in onto these slots, and I've already broken that. That's great. And I'm back. Well, I just broke that.